Hello, my name is Larry Pearson, Vice President of Marketing at Impetus Technologies. I will be your host and MC for today's session on the topic of an easy approach to ETL on Apache Spark, talking about the full spectrum of visual preparation, integration, and transforming data at the source. Tremendous response to the webinar today and a lot of interest in this whole topic of ETL on Apache Spark. Let's pause and take a look at our agenda for today. We'll start out, obviously, you wouldn't be here if you didn't have a good familiarity with ETL, but we'll do a little bit of a baseline description of the current ETL environment, some of the complexities associated with that environment, and then introduce a modern ETL architecture based on taking advantage of the capabilities of the very popular Apache Spark platform. We also will then demonstrate how the Impetus Stream Analytics product can be used to build ETL pipelines and kind of what that looks like live in a demonstration. And then most importantly, we'll also wrap up with a question and answer session. And before we get into introducing our speakers today, let me just take a minute and tell you about, for those of you who are not familiar with Impetus, tell you a little bit about our company. Impetus Technologies today is a leader in the whole area of what is commonly referred to as data warehouse modernization or data infrastructure modernization. Almost every large enterprise that we walk into today has some type of an initiative underway for data warehouse modernization and what we actually prefer to call data warehouse transformation. And the objective of these large initiatives is to replace aging EDW infrastructure in order to take advantage of some of the modern capabilities for greater scalability, to leverage the elasticity of the cloud, implement more automation, and we've got tools and solutions which help them do that, one of which you will see today in the form of Stream Analytics. The objective of that automation offering much higher productivity and velocity, less risk, fewer errors, and some tremendous work going on with regard to applying automation. Obviously, the modern data architecture environment also offers better support for advanced analytics based on AI and machine learning, and we have a whole data science practice which assists companies in doing that, and a better ability to leverage all data sources and types from semi-structured to unstructured, and ultimately to offer users self-service within all of that. And the bottom line is wanting to compete more effectively with agility and enjoy the elusive objective of having truly a single source of truth across the enterprise. Now, we work across a variety of industries. Would love to have you follow up with us if you have an interest in knowing more about what we're doing with some of the largest airlines on the planet, card processor, banks, some of the largest healthcare providers, largest telcos, and some very interesting work that we're doing across a number of different industries, and would love to tell you more about that. The time today will not permit us to spend much more time on that at this point. One of the reasons these large industry leaders are attracted to us is because we have the capability, having been a very early adopter of Apache Hadoop some now 12 or 13 years ago, for those who've been in and around the big data space as we have during that period. And it's allowed us to develop a full set of end-to-end services and solutions and platforms across 4 critical stages of the big data lifecycle, from transformation, which is this area of modernization of the legacy environment, take advantage of big data and cloud platforms, implementing a unified batch and streaming or real-time data processing, data preparation, and data access, and the full spectrum of analytics. We have a dedicated data science practice that is doing cutting-edge work in real-time analytics, in machine learning, in AI, and platforms in addition here to help make that all much easier and more productive. Lastly, the whole area of self-service, and through a sister company by the name of Kairos Insights, We're working with a number of large companies to implement massively scalable big data natively inside of or massively scalable BI natively inside of big data, be that on-premise, hybrid, or in the cloud. So before we get started today, let me just cover a few housekeeping details. As attendees, you'll all be on mute. You will be able to hear the broadcast through your audio system there, as I'm sure you're doing already. I encourage you again to ask questions. That Q&A session at the end is always one of the highlights of our webinars, and we've done a number of these already this year. If you do have any issues with audio or video, you can reach out to our on-call operations team by sending an email to events@impetus.com. It will be best to view the presentation in full screen mode for looking at the screenshots and charts and things that we'll show when we get into the demonstration portion of the webinar. We'd like to open with a poll question. We try to do this, again, another way to make this an interactive experience for you. The poll, this particular poll says, what challenges are you facing with your current ETL processes, and choose all that may apply. And there's 6 different options here, from adding new and diverse data connections, handling streaming data, changing the issue of changing and wide-ranging data formats, establishing and ensuring data quality, having the talent and resources to manage and implement all of that, and lastly, being responsive in bringing time to market. We're going to leave that poll open for the next 10 or 15 minutes, so I would encourage you to be sure to respond to that. We'll come back and give you the results of the poll and ask some of our subject matter experts to comment on that, and then proceed with the rest of our material. I'd like now to introduce our speakers for today. Saurabh Dutta is the Technical Product Manager for Stream Analytics. And he actually was part of the early team that did the design and development of the Stream Analytics platform. He leads multiple engineering and R&D efforts today related to real-time analytics and streaming ETL. And his areas of expertise is his ability to blend both business and technical challenges, and is an expert on big data, advanced analytics, and cloud computing. Also with him today is Aman Solanki. Aman is a senior product engineer for Stream Analytics, and he's responsible for implementing many of the technical features and designing solutions for complex business use cases, some of the implementation challenges that our clients may be having, and to design solutions for that, working with our delivery teams. His areas of expertise include big data, cloud computing, and machine learning. So at this time, I'd like to turn things over to Aman to start into the first item on our agenda, which is the current ETL environment. Aman, over to you.
All right. So I'm assuming that many of you know what ETL is. What are the importance that it brings to the front lines of businesses, and what principal challenges are faced while implementing an ETL solution? With all these assumptions, I would like to start with a question. Can we say ETL is easy? Well, in conversations with our customers, prospects, and partners, it is clear to us that ETL modernization brings in unique challenges. ETL processes today deal with much larger volumes of data, high-velocity data, diverse data sources, and it requires a unique capability of unifying batch and streaming data processing. It gives rise to complexities which are beyond traditional tools. Thus, we can easily say that the answer to this is an undeniable no. However, if we use the right tools and approaches for our ETL implementation, it can help us in dealing with the challenges that ETL pose, making ETL simpler for us. I will later talk about the factors that make modern ETL complex, why there is a need to simplify these processes, what tools and technologies we can use to make it simpler. Though I had assumed that most of you are aware of what ETL is, but I would like to briefly define ETL, its application, and use cases to start off with. So let me just define ETL. A phrase that comes into my mind is a repeatable programmed data movement. As we all know, in a typical ETL implementation, it involves writing some automated jobs, executing them periodically to relocate your data from one point to another in a transform format. Now let's look at the different phases of ETL. So there are 3 phases in a typical ETL process: extract, transform, and load. In extraction phase, it involves reading data from disparate sources such as databases and file systems. It also involves reading data in different formats like CSV, JSON, etc. In the transformation phase, what we do is we first bring the data that is in different formats into a single acceptable format. Later, with operations like filtering, joining or splitting columns, we will derive new columns of relevance and also apply complex business rules to discard unwanted records. In the final step, once we have transformed data ready, we will load it into the target database. Now let's look at the different applications which can be created on top of an ETL solution. ETL finds its application in a lot of domains. Numerous applications and customer solutions are being developed on top of ETL. Some of the common application areas of ETL are cloud data migration, marketing data integration, IoT data integration, even in data warehouse and machine learning. Let's start with few of these applications. In data loading, organizations utilize ETL tools for loading data from one data store to another data store. Or they might be collecting data from multiple sources and just putting it together into a single data store. In data and application migration space, organizations utilize ETL tools for loading data from one data store to another data store, or they would like to migrate their data from on-premise to cloud. In machine learning and AI applications, ETL finds its application in data warehousing, data collection, and data preparation phase of a typical ML cycle. ETL is extensively used for data collection, data preparation, and feature engineering aspect of a machine learning implementation. Data replication for disaster recovery and high availability in mission critical applications can be carried out smoothly with the help of ETL tools. It is used for disaster recovery purpose and not just for static backup. It can be used for online backup as well. And sometimes people do use it for redundancy analysis as well. While creating applications, we discussed in the last slide, we might face various challenges. So what are these factors that make the ETL process complex? Let's discuss them one by one. Growing volumes of static and high velocity data. Enterprises today are facing a massive volume of incoming high velocity data, which the traditional hand-coded ETL solutions are not capable to handle. They lack scalability capabilities. Secondly, in terms of diverse data sources and formats, traditional data sources and targets for ETL tools were limited to some legacy databases, ERP and CRM applications. But today, we have a vast number of tools and technologies for data sources and targets. The traditional ETL solutions lack extensibility capabilities to have these as their data sources and targets. Next is, there is a need for unifying batch and streaming data sources. Today, a typical ETL application will not be limited to only batch sources, or with streaming sources, but it might leverage a unique blend, having both batch and streaming data sources together in a single application. In absence of such capabilities, you will never be able to create such applications on top of an ETL solution. With data quality, there are two aspects with traditional ETL tools. Firstly, when they were fed with structured, semi-structured, or unstructured data, these tools break abruptly, as these were supposed to work with structured data only. Secondly, they have limited transformation capabilities for better transformation of data. Thus, your data result in poor quality. In terms of corrupted files and data, traditional ETL tools makes failure analysis very complex. They have limited capabilities to handle corrupted files and data. These corrupted files sometimes breaks the entire process, leading to a system failure. In addition, without a provision to checkpoint execution state, these tools are not able to resume their execution and they start all over again. Earlier, it was all or nothing approach with ETL, which in today's paradigm makes it complex to meet expected SLAs. Performance issues elevates complexity, as traditional ETL tools are not able to scale with the increasing load. They are highly resource intensive, which hampers organization to meet expected SLAs, and it also hampers the working of different tools running on top of your ETL solution. With hand-coded solutions, it is important to know that not every developer will understand each other's code very easily. Therefore, learning around these solutions has a steep learning curve. This makes the training process extremely difficult, which in turn makes onboarding new team members difficult. Hence, we now know that there are a lot of challenges involved, making ETL implementation complex. By now, we have discussed what makes ETL complex. However, there is a distinct need to simplify ETL process. So let's discuss what are these distinct needs, which motivates us to make ETL simpler. First is time to market. While building an ETL solution, it has been observed that a lot of developers' time goes into resolving technical issues. This increases the turnaround time of a solution. Instead, if ETL implementation was easy, the primary focus would have been on the use case, significantly reducing the time to market. Secondly, every organization and team strives to optimize the amount of resources or hardware available with them. We really cannot waste both time and resources available on experimentation and POCs. An efficient tool will allow you to experiment with technologies and at the same time focus on utilizing the available hardware itself. We have seen convergence of roles in many organizations. Developers must work on multiple assigned tasks which require different skill sets. It is hard to find expert resources in the organization these days, which can dedicatedly work on tasks such as your ETL workflow. So these are the few key reasons which motivates us to simplify ETL process. Now I will talk about major building blocks of an ETL architecture. So the major building block of an ETL architecture consists of core ETL functions, a processing engine, and an enterprise readiness block. In brief, core ETL functions are the operations which provides connectors as source and sinks. Also, it is equipped with functions which act as transformations for converting your raw data to desired format. Next is processing engine. It is the one on top of which your core ETL functions will run on. This is the backbone of any ETL tool. The enterprise readiness block refers to key functionalities needed by any tool to be adopted into an enterprise. For example, security. Let's talk about this blocks in detail. So a common core ETL function will consist of connectors to read data from different databases like Oracle, MySQL, from file systems such as HDFS, from queuing systems like Kafka and RabbitMQ, and from cloud and IoT-enabled sources like Kinesis and S3. It will also consist of transformers for achieving common operations like filtering data, enriching data, joining or splitting data values, performing aggregation on top of data, and pivoting operations. It also allows you to achieve complex operations with custom transformations, which can be written in any common programming language like Scala, Java, or SQL. Finally, it consists of connectors to write data again to Kafka, Kinesis, and other such stores. Processing engine, also known as execution engine, it can be any proprietary engine or any distributed scalable advanced processing engine. ETL functions typically work on these processing engines. In enterprise readiness block, in detail, it asks for features such as multi-tenancy, security, extensibility, and monitoring. For example, as part of monitoring capabilities, it would like to have provision for monitoring your ETL jobs so that you can continuously watch for resource monitoring and can generate automated alerts. So these are all limited to earlier traditional ETL processes. If we want to talk about modern architecture of an ETL solution, it needs certain add-on capabilities and a rejuvenated processing engine to work with. So what all are these add-on capabilities which modern ETL tool must have? Let's have a look at them. So first is data profiling, blending, and cleansing. ETL is all about dealing with data. Modern ETL tool must have strong operators for effectively achieving data blending, cleansing, and profiling. Secondly, as an important capability, modern ETL tools must allow orchestration of multiple ETL jobs as workflows. It should also allow integration of such workflows for achieving complex use cases. Data science capabilities like having provisions to fill missing values in your incoming data from a model is one good feature people consider a must-have. We are also analyzing modern ETL tools from visualization perspective. Unified batch and real-time processing. ETL is not limited to batch processing anymore. Today, ETL finds its application in many real-time and near real-time applications. Hence, modern tools must have strong unifying capabilities to cope up with the emerging needs. From the flexibility point of view, modern ETL should have or should offer extensibility as well as reusability capabilities in the form of custom UDF and transformations. And finally, in the modern big data world, where data-driven applications and solutions are crucial factors for organizations' success, ETL tools must be compatible with vast components of Hadoop ecosystem for providing them edge in terms of analyzing large-scale big data. Modern ETL solutions demand a distributed scalable execution engine which is capable of doing parallel computation at massive scale. With all these needs and considering the complexities and hardness that we discussed earlier, we believe Apache Spark can be a good fit for ETL. Spark is a general purpose processing engine capable to process big data at a tremendous speed. and is very proficient in ETL tasks. And this is not just a saying. The number of features that Spark offers, we can certainly say that it is the next generation choice for implementing ETL solutions. Some of the key features which make Spark perform well as ETL tool are: it is open source, accepted widely among developers as an ETL tool. Large number of people are contributing to Apache Spark, and it is continuously evolving. It offers data processing with massive scalability capabilities. It has unified APIs for all the phases of ETL. It has multiple language support, such as it provides APIs in Java, Scala, and Python. It has numerous sources and targets to read data from and write data to, and it is extensible as it allows you to create your custom sources and targets as well. It has built-in machine learning capabilities, which is an add-on capability modern engineer seeks in an ETL solution. Apart from this, Spark offers unified streaming and batch capabilities to write your modern ETL workflow as both batch and streaming jobs, as well as you can create a mix of both. So, for example, in an application, you can have both streaming and batch sources together in a single application of Spark. Here is the word cloud representing all the built-in and external connectors available in Spark to read data from and write data to. It provides built-in connectors to read data from JDBC, Hive, S3, and HDFS. Also, it implicitly allows users to read data in JSON and Parquet format. It also offers external connectors to extend its sources and sync capabilities to NoSQL databases like HBase and Cassandra, and also to indexing stores such as Elasticsearch. It also has connectors to read data in Avro and CSV formats as well. Apart from the other factors that we discussed earlier, there are certain other factors which enables us to create production-grade streaming application on top of Spark. Let's discuss few of these factors. Spark provides end-to-end reliability and correctness guarantees for your jobs, whether they are streaming or batch jobs. With chaining of multiple transformations together, it allows developers to create complex transformations or to apply complex transformations on your input data. Spark provides a mechanism to deal with late or out-of-order events. It gives a smooth handle to tackle such events in some time-critical applications which are created on top of Spark. It can convert your data to a more efficient storage format, and it enables data partitioning by important columns, which removes a lot of burden from developers to think about such crucial factors while implementing a solution. So with all these factors, we can create quality streaming applications for enterprises, which are production ready. That is all I wanted to cover, and before we move forward, let me hand it over to Larry to announce the poll results. Over to you, Larry.
Terrific, Aman. Thank you very much for that interesting description. Let's take a look now at the poll results. You will shortly see those shown on your screen. If we could close the poll now and display that, that would be terrific. There we go. You should be able to see that on your screen now. We've had a great response to the polling. And if you look at the two categories of data quality and adding new and diverse data formats and sources, we've got 52% had said that data quality is their number one challenge, and 51% adding new and diverse data connections or sources. Close behind that, really, though, is handling streaming data and also productivity, skills, time to market. So you can see there's a broad range of factors related to complexity that possibly using things like Apache Spark and some of the tools that we're going to show you now may help address all of that. So thank you all for your participation in our poll. I'd like to turn the presentation now over to Saurabh Dutta, but let me also remind you to keep those questions coming in, which we will aggregate and address here at the end of our webinar. So Saurabh, if you'd take over. Thank you.
Thanks, Larry. So we saw, various advantages of using Spark. And, it really comes bundled with a lot of features as well, especially around ETL. I think whenever organizations try to create their next level architecture, Spark is almost, like one of the choices that comes up in their mind. But for some reason or the other, enterprises have, still not been able to prominently adopt Spark as their core engine for ETL. There are still significant challenges being faced by organizations to move or choose Spark completely as their single technology for their ETL processes. And, there are good reasons for it as well. So the first one would definitely because it requires a lot of hand coding. And when you do hand coding, it really defeats the purpose. No one is interested in building an entire application end-to-end, hand coding everything from scratch. And not only does it impact the timeline, but also impact the quality and efforts that are spent on testing. Then there is also a steep learning curve like you will encounter with any other new language or framework that you go ahead and try to learn. So, when we talk about Spark, just to start with, you will need to know about data collection, coding transformations, how you will debug your applications, and also understanding the deployment model. So, once you have some sense of this, only then you could, get started with building an application and taking it to production. Another significant challenge is finding trained and skilled Spark developers. You will always get resources with basic understanding of Spark and the paradigm, but it is always difficult to get experts in this domain. And when you have developers with lack of familiarity, it can seriously affect the outcome of the project. No UI, yeah, this is one major gap. So Spark doesn't come with a visual interface. So people have to actually hand code everything from scratch, as we were previously also discussing. And although the Spark community and the creators of Spark have tried to make it simple in terms of coding, but still the visual element is completely missing. Then, when you write your core functionality, there are a lot of other things that you require. So, when you develop something in Spark, you may be able to develop the core functionality. You may be even able to write it fast. But then, we also need a lot of other supporting functions. In order to push something into production, you will need things like security. You will have to make sure that you are able to onboard users. You will have to make sure that, you take care of failures and retries. So there is a lot of, additional coding that you require. And, if you use Spark, you have to write these kind of codes as well. So hence what we really need is something that could save our time to get started. And at the same time, we don't want to be limited by some of the other stuff, and we want to leverage all the advantages that Spark provides. And now, once we realize the gap between the richness of features that Spark can offer and the interest of enterprises to adopt it. So this brings us to the next logical step, and that would be definitely to fill the gap. we need something built over Spark, but at the same time, we don't want to lose all the core ETL functionalities, the enterprise readiness features, and if we could get all the add-on features that Aman just described in one of the slides, that would definitely be an added plus. So at this point, let me introduce and talk a bit about Stream Analytics, which is a self-service data flow and analytics platform. Stream Analytics enables creation of complex batch and real-time workflows, or what we call as pipelines, and under the hood, it is powered by Spark. Okay, yeah. So Stream Analytics is developed ground up, keeping the platform approach in mind. It has all the ingredients in place to develop a fully functional ETL pipeline. It focuses on making things really easy for the user by providing a graphical environment over Spark for various processes and tasks. You get a canvas which you can utilize to drag and drop various pre-canned components, including sources, targets, and various other transformations to create an ETL pipeline easily and fast. The interactive workflows that are created runs in a distributed fashion over Spark without the user having to worry about coordination. Then, it can also very easily integrate with a lot of other external systems because people really don't want to change. So that is something which we have kept in mind while we were developing Stream Analytics. We can easily integrate with a lot of existing systems, and also we can integrate with your existing Hadoop infrastructure and can run jobs, Spark jobs especially, on your enterprise cluster itself. We have also given a number of ways to coordinate and integrate with a lot of external systems on same or different platforms, and we have things like external lookup calls. You may want to do a lookup into some sort of an internal database or some sort of a cache. So all these features are present in the system so that we can really fit well in the ecosystem. Auditing again is an important feature that we have taken up, where we really want to track who is doing what in the platform. Otherwise, when a lot of people work together, things tend to mess up, and we really want to make sure that this doesn't happen when you use Stream Analytics. So there is really a trail which gets created when any user does something in the platform. In a lot of ETL processes, what happens is there are different teams working in silos. We also want to get them together on a single platform. So there are a lot of features which enable collaboration in the system. Like in a lot of other applications, you get this feature of checking in code, right? So those kind of features like checking in and using a version control system, we have integrated all of those as well in the platform so that you really have a strong control over the source code. Extensibility is one crucial feature wherein, along with various out-of-the-box complex transformation, user can very easily extend and write custom transformation and functions. Once the custom logic that you create is in place, you can then register and reuse it in your various pipelines and workflows. Once the pipeline is built, it is just the starting point. Taking it to production is a long journey. Hence, we need support for various other features to make this journey possible. And we have carefully worked to incorporate all these features in the product so that you can have complete control on what you have built, and this should be end-to-end. So keeping that in mind, just for an example, if we take an example of testing, so once you build the draft pipeline, you may want to test it against various different data sets. And we really want to test it for various permutation and combination. And Stream Analytics has an option of writing test cases so that you really can build robust pipeline and test it against various scenarios. Then we have also various features built around continuous integration and delivery. And when you build batch-based use cases, scheduling is something which is very important. And when you have pipelines that are interdependent and you want one pipeline to finish first, and based on the outcome of the first pipeline, you may want to orchestrate another pipeline. So all those features also come bundled. And finally comes performance and monitoring. We have to make sure that what we have built is performant and is processing data as expected. If we may also have to configure certain alerts in case something goes wrong, we may also configure alerts on these performance and monitoring parameters so that in case of a failure or something goes wrong, users can be alerted. You can send out emails so that people are aware and they can get on to the system and fix it. With this, I would like to take you through a quick demonstration of how you can build an ETL type of pipeline in Stream Analytics. And here I plan to cover how you can connect with various sources to do the extraction, combining and joining various data sources, how you can clean your data, and then we'll move on to data enrichment and how you can derive new values. And finally, I'll show you how you can persist the data in a data store. All right. So I'm clicking on the pipeline page. So here we get a quick glance of how our system is. We get the details of the system in terms of the memory and cores that are available. And this is the listing of all the various workflows that we have created. So, one important thing is instead of working on the logic and, typically in any platform, you'll have drag drop components. What we are also focusing is, having the data first approach in place. So let me just turn on this inspect button, and you'll see that, there is that one inspect thing that is getting launched. So yeah, while this comes up, so what I was talking was we really allow the user to get a visual representation of not only the pipeline, but also on the data. So as soon as you receive the data on your source, so here we have taken two sources, as soon as the data is received at the source, at each step, how the data is changing, you can now see it on the UI itself. So while I go ahead and explain the use case, let me take you to the the kind of data that we'll be processing. So I've taken two files. One is around around customers. So this has fields like customer zip code, customer city, gender, age, annual income, and all that stuff. And the second file that I'm referring to is around the orders. So any customer who places the order, what is the status of the order, when was the order delivered, when was the order approved, and stuff like that. So we have taken two files, and for that reason I have taken two different sources out here. So as soon as if I right click on one of the processors, I can configure a particular data source, and configuring it is very easy. So you just have to specify the type of file that you may want to process, and specify the connection of where you will be pulling in data from, and maybe specify a simple query of how you want to read the data. So in this case, first source is for the orders, and the second one is around customers. In the poll as well, we saw that people are struggling with adding new sources. So in Stream Analytics, adding a source or any transformation operator is extremely easy. We have, exposed certain interfaces. So as a user, you just have to implement those interfaces and, write your own custom logic. Once you write that, you can, just register that, and it is available as any other component in Stream Analytics. So these are, what the sources are. And similarly, I could add many other different sources as well. So if you don't see a source out here, maybe what you may be interested in is you will write your own custom source and register it here, and it will be then available for use. Similarly, for all the transformation, we have various transformation operators which are available, and we call them processors. So simply you can drag drop and connect them to create your ETL pipeline. One of the other important things is, now in your ETL platform, you can also have analytics in place. So you can at any point develop your own algorithm, especially, from the ETL context. You could use it maybe to enrich the data, maybe to, find out missing values or imputation. So in all those scenarios, you could have your model trained inside or outside of Stream Analytics, and you could use those algorithms over here. I have used one. I'm going to show you one quickly. But what is important is you have this entire list over here, and you could use any of the machine learning algorithms now in your ETL workflow itself. Similarly, for persisting the data, we have something called as emitters. So you can now persist your data not only to traditional stores like RDBMS, but you could persist the data into some sort of a NoSQL store or some sort of a cache, or even push the data into WebSocket. So all those possibilities are now there. Now you can see that when I click on the source over here, whatever data we receive, pictorial representation of the data is shown over here. So I could really see how my data is getting landed over here, and what are the fields that are coming in. So we have tried to fetch order related data over here, and similarly if I click on the customer details, it will just take a couple of seconds, and whatever data we are receiving at the customer end, that is also shown over here. One interesting thing is, here you could now apply just simply drag and drop a data quality operator, and you could do all sort of data quality checks here itself. So suppose you want to get rid of null values, and you really want to push all those records with null values into a separate error queue. You can do all of that with, for example, you can pull in a data quality operator, and you can handle those. Now, looking at the customer data, I could see that there are some inconsistencies in the data as well. So here, if I look at the gender, since we are joining two sources, and one of the source, let's say, had same data, and similarly the other one has different kinds of records. So just for female, we have F, female which starts with a small f, and then female with a capital F, and similarly for male as well, we have certain records. So what I could do is, after I join the records, so here I'm joining these two sources. After I join the records, I could actually do some sort of a correction and encode free-form values, and simply with help of an expression, I could replace and do correction over my incoming source. Now here you will see that all the records which are coming in now, the gender is corrected. So in this form, this is really important when you take care of data quality. Things like filtering, these come bundled with Stream Analytics in any way. So I'm not going into these details, but yeah, this piece is important. So here, here we have just filtered whatever orders were delivered, and if I come back to the machine learning part of it, here what we are doing is we are trying to bucket various records that are coming in. So again, what I need to do is I just need to drag and drop a model which is again previously created in Stream Analytics itself. And what I need to do is, when I'm dragging and dropping a machine learning model operator on my canvas, I need to select whether I want to do training or prediction. In this case, I'm just doing prediction. I'll just specify whatever features are required. So in this case, I'm bucketing the record based on age annual income and gender. So these become my features for the model. And based on that, I'm trying to predict in which bucket the record will fall in. So if I click on the inspect button over here, and now if I just browse a little bit, I'll see that there is something called as model output, and it has automatically created 5 buckets because I'm using a k-means algorithm where we have specified k as 5. So because of that number, we are getting 5 buckets from 0 to 4. And now, if I click on one particular bucket, let's say I clicked on the first one, you could see on the screen itself that there are certain values or attributes which have gone gray, and similarly there are certain attributes which have gone pink. So here I could see a correlation as well. I could do this on any of the fields, and automatically whatever is correlated with will be highlighted. So in the 0th bucket, I could see that the annual income, whatever records had a very high income, they fall in this particular bucket, and similarly the mid-age group of the records. All right. So I think because we have limited time, I like to cut the demo a bit short. And coming back to the presentation, let me quickly summarize what we saw today. So now that we saw the pipeline capabilities of Stream Analytics, some of the highlights that I would like to go through today include, Stream Analytics is a unified platform for not just batch processing, but you could do a lot of real-time processing as well in terms of ETL workflows. It is again built on top of open source, so current focus definitely is around Spark, but you could integrate a few other open source technologies for processing as well. It enables seamless ingestion to multiple technologies. So different organizations may have different needs, but with a vast range of ingestion sources and targets, we really give the power in the hands of the user to pick and choose the best one. And one of the biggest advantages that we see with Stream Analytics is the ability to integrate data science now in your ETL workflows. So far, the enrichment of the data was only done in a limited ways, and the quality of enrichment really goes to the next level when we now use machine learning and data science capabilities. So, the best part is whatever you build with Stream Analytics minimizes the need for testing, and the pipeline that you saw on the screen just a while ago, if you have to deploy it on production, that process is also simple, and it needs minimum human intervention, and therefore the chances of introducing any errors are negligible when you take this kind of a pipeline from a development platform to production. With this, maybe I'd like to conclude my talk for today, and let's take up a couple of questions, and over to you, Larry.
Great, Saurabh, thank you very much. Before we move to questions, I have just a couple of things that I would ask you to do. Again, there's still time to get some of your questions in. We have a number of very interesting questions that have come in already, and we'll get to those momentarily. I would also ask you, though, to rate your experience today. That's very important for us as we plan our approach to future webinars, and you'll see an opportunity to provide that feedback on your screen in addition to those questions. And we have a final poll question also, which we would like you to look at, and you'll see that on your screen here shortly. And it has to do with those of you who may want to have us provide a deep dive on this. You've kind of seen, kind of an overview of what it is that Stream Analytics brings to the ETL environment, and certainly we'd be happy to do a customized deep dive of that with you, and you can request that through this screen here, and then rate your overall experience from 1 to 5 overall. We'd like now then, that being the case, to go ahead and look at some of the questions that have come in. For example, there is a question here about can you talk about metadata lineage and maintenance? And sort of between you and Aman, who would like to take that one?
Yeah, let me take that up.
Okay.
So definitely metadata and lineage is one crucial thing when we talk about ETL. And in Stream Analytics, the way we support is we have support for integrating with Apache Atlas. So whatever, information, be it on the schema of the incoming data, or the data is, how the data is getting moved from one place to another, all of that is taken care, and we leverage Apache's Atlas for this particular purpose. And to answer your question, definitely we do have support for metadata lineage. On the maintenance side, I'm not too sure, but getting a queue. No, I'm trying to just guess. Probably once the pipeline is deployed on production, how do we maintain it? I'm assuming this to be the question, and the answer would be yes, definitely. Once the pipeline is deployed on production, you can always monitor how your pipeline is doing in terms of the number of records it is processing, number of batches it is processing, and stuff like that. So both lineage and maintenance are available with Stream Analytics.
Okay, great. Another question then has to do with our integration to Databricks. Do you offer any integration with Databricks? Aman, maybe you want to answer that.
Yeah. So yes, we can integrate or connect with Stream Analytics with Databricks. You can submit the pipeline created in Stream Analytics onto Databricks. It will on the fly launch the cluster, Spark cluster, and also you can provision automated scheduling of those pipelines, and it will auto scale as well. So yes, definitely we can integrate Stream Analytics with Databricks.
Okay, great. Thank you. There's another question here. Is the GUI that was shown proprietary to Stream Analytics, or can be customized by the client? Saurabh, you want to answer that?
The GUI is definitely to an extent proprietary. I'm not sure what we mean when we say customizable for a client. But yeah, if you just talk about the look and feel, we are definitely open for OEM partnerships, and with some of our OEM partners, we have completely changed the look and feel so that it was rebranded, and the complete look and feel could definitely be changed. But as far as the underlying engine is concerned, this is particularly made for Spark, and typically whatever you build on this GUI, that is, whatever pipelines you build, all of that gets submitted on top of a Spark cluster itself. So yes, in terms of if you want to do some sort of white labeling, but no, if we, let's say, want to run it over a proprietary engine itself. So the GUI is not a piece that we, I would say, share with our clients in a standalone way. It is always bundled with the processing engine as well.
And the only thing I would add to that is that we've been very successful in working with our clients where there is a need for some specialized operator to create specialized operators as a customized a customization feature also, and that's been very, very helpful. The next question here says, do you have data quality checks in this pipeline? If so, can I create a reference set of rules and reuse them time and time again? Do you want to step up to that?
Sure. Definitely. So we do have these kind of checks, and you can reuse these checks as well. So in Stream Analytics, we have an interesting feature called importing and exporting of pipelines. So let's say I, as a business user or any other user, I want to create some set of reference rules. I could create that, and if I need to reuse those rules, I can always re-import the same pipeline into multiple different workspaces when I need to share it with different users, or if I want to reuse for any of my own use case, which is maybe different from where I have been currently using it, I could re-import it in my workspace again with a different name, and those possibilities are also there. So yes, you can definitely create a reference set and reuse these rules.
Even with the help of rules as well, right?
Yeah, so rules is something, you can create rules externally. If you have, an external rule engine that you support, so you can create your rules externally, and we can again import those rules in our system as well.
Okay, great. We've run out of time. There are a number of other questions here. Let me just give a kind of a broad answer to several of these, and those that have not been answered, we'll be sure to get out to you in the form of email. There was a question here that says, how easy is it to migrate existing SQL ETL scripts and pipelines to Spark? And we actually have an automated platform for workload migration of a variety of enterprise data warehouse workloads, one of those which are ETL-related scripts. So again, we've got a lot of experience in that area, have built some automation tools, and if you have that need, we'd love to talk to you about that. There's also a question here that says, what are some of the use cases other than ETL that you've solved using Stream Analytics? There is a separate website, www.streamanalytics.com, that goes over all of the different ranges of vertical solutions and industry use cases beyond just ETL. Of course, our webinar topic today was limited to a specialized focus on the ETL use cases. Certainly there's a wide range of use cases that are achievable with Stream Analytics, IoT being one that comes to mind, predictive analytics, predictive and preventive maintenance in the industrial and heavy asset equipment environment, and a number of other typical applications for streaming data analytics, clickstream analysis, Customer 360 related use cases, and you'll see a description of many of those on our website. And the rest of these, I'm just glancing down, are things that we'll have to get out to you in an email format. You see on the screen here for more information. You can send an email, inquiry@streamanalytics.com. Also do a number of proof of concept work with our clients. We do offer a free download of Stream Analytics. It's described there at streamanalytics.com, and we also have a complete cloud-based trial. Further, there are 3 major conferences coming up where we will be sponsoring: the Gartner Data and Analytics Conference in Orlando here week after next, and then 2 weeks, then the week after that in San Francisco. We'll be back at the Strata Data Conference, and then come a month later at the end of April, we'll be at Spark plus the AI Summit. Again, make sure you do rate your webinar experience. If you want a deep dive of the product, indicate there, and we'll follow that up. Otherwise, you see the other references here on this screen as to how you can get more information. Thank you very much. Sorry we ran a little bit long. Have a great day.